Well, this looks to me like we have a linear differential equation, usually of the form y prime plus some function of x times y, and then equals some other function of x. And this one is set up exactly of that form, so that means that the p of x is going to be this 2x. And we're going to be using the integrating factor, which comes from take e and raise it to the power, the integral of that px. So first we need to take the 2x and integrate that. So if you integrate 2x, that is x squared, and we don't need to use the plus c until the very end of the problem. Then the integrating factor is going to be e raised to that x squared. And the next thing we do is take the equation and multiply both sides by the integrating factor. So we've got y prime plus 2x times y equals x. And now multiply both sides by e to the x squared. So there's e to the x squared times y prime plus the 2x times e to the x squared times y. And then on the right side, x times e to the x squared. And then remember that when you get to this point, basically the left side came from somebody doing the product rule. And the product, you can just use these two guys, but just take the y prime off of the y. So it's e to the x squared times a y that somebody did the product rule on. And as you can see, when they did the second half of the product rule, when you take the derivative of e to the x squared, it would be e to the x squared times the derivative of x squared, which is 2x. And then on the right side, it just stays the same for now, x e to the x squared. And then get something like a blue pen and say, integrate this side with respect to x and integrate this side with respect to x. On the left side, the integral and the derivative cancel each other, so we just get e to the x squared times y. And then on the right side, we should probably use u substitution. And so I'm going to say, if you let u equal the exponent, the derivative of that is going to be a 2x dx. And the problem does have x times dx, but it doesn't have the 2. So multiply both sides by a half, and then it's ready for the u substitution. And so it's then going to be, looks like I need to move this just real quick. Let me move it down here. Okay, so then when we're doing this red part and doing the integral, then it's going to be, you could factor out the 1/2 and then integrate the e to the u du. So that's just going to be 1/2 e to the u for the antiderivative. So 1/2 e to the u, but u was an x squared. And then plus a c. So now we've done all of the integrating and all of the calculus, we just need to solve for y. So you could divide both sides by e to the x squared, divide by e to the x squared, and divide by e to the x squared. And then there's a lot of canceling, leaving just y on the left side, and canceling, leaving just a 1/2. And then usually the way to write the last part is not as a fraction, but just leave the c and then rewrite the e function with a negative exponent. And there is the solution.